titled Our Air and Pollution, and it really is just kind of the goal is to get to kind of an air quality 101, the basics of air quality, to get students to understand kind of what's in the air that they're breathing, think about where they can get air quality information as well. So a lot of this activity is actually not so much classroom or hands-on in the sense that there's not any little setup that they're going to do. A lot of it's computer-based. They're doing some research ahead of time to try to get some more information about air quality. So they'll learn again about what's in the air we breathe, do some research, and how to kind of interpret some of the information that's out there. So it kind of starts with a description of, you know, what's in the air that we're breathing, right? So we know, I always tell students when I do like lectures or anything like that, you know, air is mostly pretty boring, right? Like 99% of it we understand entirely what it is. Actually like 99.9% of it is just like oxygen, nitrogen, and like argon. That's like 99.9% of all the gases that are in the air. But there's also a lot of other components that are really interesting that even though they're in such small amounts, they mean a lot for climate, for health impacts. Things like ozone and carbon dioxide, and particles, which is the biggest focus of Kids Making Sense here. So, and I guess one of the things I've done in the past to kind of get people to understand, welcome back, I was saying, the next section we're getting into is kind of air quality 101. One of the things I've always pointed out is, you know, to give people kind of a sense of scope, the size that we're talking about here. So if a percent is a part per 100, you know, we're talking about carbon dioxide as a part per million, right? So one carbon dioxide molecule in a million gas molecules, or 400 of them in a million gas molecules is what's interesting. That's what's affecting climate so much. So it's really interesting to think about kind of context in that regard. Ozone is 60 molecules of ozone in a billion of them are what's enough to cause health impacts, affect your eyes, affect what, you know, the air you're breathing, things like that. So, unfortunately, I should say unfortunately, so it's interesting with Kids Making Sense, the way it's set up. So particles are the big focus here. Honestly, because they're easier to measure with small sensors. There are small sensors that exist for things like carbon dioxide and methane and other gases like that, but they're not as good. They're not as reliable sometimes, and it's harder to do the more toxic compounds with anything really small, right? A lot of the times that I'm saying we're installing, you know, these fence line monitors at refinery. Each individual analyzer costs somewhere between $60,000 and $120,000. So it's not like it's that easy to. And yeah, we're installing like 42 of them at one refinery alone. So that's $7 million worth of, you know, equipment right there. So that's not really feasible for a lot of people. So it's nice to do things like small sensors, and it's really, the technology's improved very well for particle measurements. And not only that, but particles are super important for air quality. What do we mean by that? Like, you know, they're pollution sources, right? So it kind of gives them an understanding of what is pollution. Pollution is basically like any substance in the air that can cause harm to humans or animals, reduce visibility, things like that. That's all considered pollution. And a key component of what we are calling pollution is that it's regulated by both at the national level, at the EPA, Environmental Protection Administration, or at the state level, things like the California Air Resources Board helps set up the kind of laws that are going to dictate what at the more local level, things like the Air Quality Management District or Air Pollution Control District is going to go ahead and set regulations for targets that we can meet for emissions. So it's kind of getting, this chapter is set up to kind of help students understand what these different types of pollution are and how they're regulated. So part of the discussion in this chapter is also just understanding, well, what is a particle? What do we mean by particle pollution? So particles, we know, are really kind of complex mixtures of extremely small solids and liquids suspended in either air or suspended in liquid, it turns out. And it's made of a variety of different materials, things like organics, dust, sand, smoke, pollen, metals, paint flecks. All that stuff is part of what can be small particulate pollution as well. Particles, they'll learn, and we'll talk about this a little bit more, is they can be either directly emitted or they can be produced chemically in the atmosphere, what we call secondary pollutants or secondary particles. Secondary organic aerosol, if that's ever a thing people have heard of, is a big topic of research, understanding and characterizing particles that are made from gases. They're extremely small. There's a nice little diagram here in the teacher's guide that gives people a sense of what we're talking about here. So when we say pollution that's regulated by the EPA, it's not all particles that are measured or that are regulated by the EPA. It's only those of a certain size. So when we talk about particulate matter, we're talking about two sizes of particulate. So we got those that are 10 microns and smaller, PM10, or things that are PM2.5, which is 2.5 microns and smaller. And so this guide gives you a nice little kind of visual depiction of what that is. You know, a human hair strand is about 50 to 70 microns, and so we're talking, 5 of those across makes PM10, or, even more of those are going to make PM2.5. So we're talking extremely small. Gives you a little reference point to think that blood cells are somewhere in between PM2.5 and PM10. You can't see that visually, a lot of times microscopic. And things like sand or dust are going to be a little bit bigger. We can see those more easily. Here's a little fun fact. There are 25,400 microns in 1 inch also. So you can think about how small we're talking here as well.
It's a good one. I like that. 25,400.
25,400 microns in 1 inch, right? That makes sense. 2.54 centimeters. So it's just some conversions. Unit analysis, that's what I was always told when I took class, like chemistry in school, was like, units are like the only thing that matters. So if you can work out the units, you can work out the answer.
An Avogadro's number.
You got a good science teacher.
Yeah, when I would teach, Gen Chem and things like that when I was in grad school, and the answers you'd get sometimes, it's like, oh, I got -5 grams. And it's like, really? You can have negative mass? I think you've discovered something.
I had this conversation with a student the other day who had a number on his paper, and he told me that, oh, those units don't matter. I said, oh, that's great. You want to come work and do some gardening at my house? I'll pay you 100. I said, then you work all day and I give you $1 because it's 100 pennies. I said, I think units matter. He's like, oh, yeah.
That's good. I like that. 100. I'll pay you 100. So yeah, a little bit more what's particles, some size things. The next kind of section of the activity also talks about, because particles are so small, they move around easily. How long can they stay in the atmosphere? How long can they be, for how long can they be transported? So kind of talks about particles will stay a particle in the air, floating around kind of indefinitely unless one of these 3 things happens. So we can get sedimentation, particles settle on the surface. A little bit what we're hoping is going to happen with our index cards, that there's a good amount of sedimentation happening right now, so that we can collect some particles. Condensation, you can get, if there's wet outside, you can kind of wash away particles, right? We know that they can uptake water very easily. There's hygroscopicity. There you go.
Hygroscopic.
Yeah. Hygroscopic is the thing that you're talking. We can measure that, how well a particle can uptake water. Turns out, depending on the temperature and the humidity, quite well. So that can help wash away kind of some of your particles as well. Or we can or they can coagulate a little bit more. I was talking about the secondary formation. So you can basically get particles, eventually they can collide enough together that they build up on each other and aggregate. You get a much larger particle and that can fall out of the sky a little bit easier. So the guide itself, and I don't have it on the screen unfortunately, has a little bit of a table here that kind of discusses particle sizes, how they're removed from the air, and therefore that means, how long would it stay in the air potentially, or the typical distance it could travel. So ultrafine particles we talk about, so things that are 1 micron are smaller. Their main removal processes are going to be coagulation and condensation. That can take anywhere from hours to days, and generally, those types of particles aren't going to move as far. You're talking maybe up to 100 meters or something like that, typically. Those that are PM 2.5, sedimentation is kind of one of the main ways that it's removed. It's going to gather on a surface. It could take days or weeks, which means you can move somewhere in the range of like, hundreds of meters or kilometers up to a couple kilometers. Large, or even further than that, it can go several thousand kilometers. The PM10 particles also kind of tend to mostly sediment to gather on surfaces. That can take somewhere, as little as a few minutes or some hours, and they can travel kind of more in the tens of kilometers as well. So things like smoke, I mean, that's the most obvious when you see a wildfire happening, and all of a sudden that smoke is transported a couple hundred miles away. That's a lot of that is the PM10 particles and PM2.5 particles are moving along and affecting that. So I'm sure you guys know all about smoke in this area.
Unfortunately.
The Thomas Fire, right? 2017 was the big one. So.
And the Woolsey, and the
the Woolsey fire.
yeah.
Yeah, that was another one. Yeah, it's kind of almost hard to keep track.
Maria Fire was just last week.
I was telling folks that I always say this. A lot of what we did when I was at NASA was understanding fires, and it's always this like double-edged sword because you get excited when there's a fire in terms of scientific, potential there. There's so much information we can measure and learn about. But then you don't want to be like, I'm excited that there's a fire. It's like awful because ultimately we know that they're costly, destructive. So I got a weird place in my I like fires, but I don't like fires, but I think they're just really interesting scientifically. So there's so much information there that we can learn. Places like NASA and NOAA put a lot of money into studying fires and emissions. There was a big campaign that just wrapped up this summer called FireX-AQ. It's an acronym because it's NASA. It stands for something, but basically it's studying fire emissions and their impact on air quality. So then they did that this year, and then last year there was another one that NCAR put on. It's like right now it's a really hot topic as well in the big research agencies is understanding the impacts of fire. So I guess that's kind of it here. Well, that's all it has here. So, but I want to talk to you guys a little bit. So some of the activities they'll be doing here and kind of what they're researching is understanding, what is air quality, understanding what the EPA Air Quality Index is. I'm sure you guys have heard of the AQI. So it kind of has them going online researching what their air quality forecast is for their area, understanding the scale of the AQI, which I'll talk a little bit more in depth in a later section. They can go to websites like the American Lung Association puts together a kind of a report card. It's State of the Air, as they call it. And so I just kind of went online because I was curious to see what Ventura County, what their grade is not good. So part of that is ozone. I mean, so again, what we're talking about is particle pollution. And they'll learn that kind of air quality can be measured in two ways. Ozone is one part of it, particulates are another part of it. So therefore, each grade on this American Lung Association website could be based on those two factors. So just so happens that Ventura, like many parts of California, have the double whammy where they're terrible for both. So at least in the 24-hour particle pollution, so each day is not great, but overall it's not the worst for the year. I don't really fully understand how that works out. I can go into the details a little bit more. But, if you scroll down, it gives them some more information about kind of what, anything below this average is acceptable. You can see, it's really nice, you can see in Ventura County just over the last 25 years, or 20 years, how much better the pollution's gotten. So that's kind of a nice little, for the most part, I don't know what happened. That's probably fires.
Yeah, totally.
We're starting to learn that, wildfires are becoming, I guess they're becoming larger and more impactful, right? They're just I could talk on and on about fires and stuff like that, but just suffice it to say, that's a big, and students can see it, especially at the high school level. They know what it was like a couple of years ago when you had these big fires, or last month even. You can kind of see the impact of things like that coming up. I guess here's the annual particle pollution measurement that it's got on here as well, so that's even gotten better over the last few years. So it's a really neat kind of website, a lot of information on here. So this part of it is you know, it gives you some information here, some ideas, but you can just go and research ahead of time and kind of come up with some more things that you think are interesting to point out to the students as well. Who's at risk, you know?
Another source, Josette, is there are a couple of named environmental justice communities in Ventura County.
Okay.
And so under Cal EnviroScreen, and you can access
Yes.
that through the web as
Yeah.
well, those are identified, and they are in the Oxnard Plain, where health effects are, I mean, really dramatic, like 95th percentile for asthma, and
Yeah.
on the avenue in Ventura. So it becomes particularly relevant to populations in those areas.